Hey geeks, welcome back to BiharGeeks. So today we are going to solve a very popular problem, that is binary tree maximum path sum, which we are going to implement in Java. This problem is a common coding challenge where we need to find the maximum path sum in a binary tree. Okay, so here the problem statement says that we have given a binary tree and we have to find the maximum path. A path is defined as a sequence of node from starting to any node in the tree along the parent child connection. Okay, and the path must contain at least one node. So as you see the example here, uh, we have a root like this, and whenever we do sum of all, we need to find the maximum thing. So here, when we do the sum up of 2, 1 and 3, we will get a maximum value that is equal to 6. Okay, as you see in the another example, we have this root. So if we move to like 9 minus 10 and 20, so it will be 10. 10 plus 9, that will be equal to 19. So it will be not like a maximum thing, but as you see that the optimal path that it get it, like 50 plus 20 plus 7, that will be the maximum value. That's why result was 52 only. Okay, so the approach I'm going to follow here, that I will use the concept of DFS only, that is a depth first search. So we traverse the tree using DFS only. Okay. Secondly, we will calculate the maximum path sum of each node. That is, we will compute the left and the right subtree sum. Okay. Secondly, we will consider only positive contribution. Like as you see that there is a negative thing also. So we will just simply ignore that. Okay. And then we will calculate the sum including the current node also. And third step will be like we will keep the track of the global maximum. We will keep a global variable where we will keeping the maximum sum up. At each node, we will calculate the maximum path sum including the both left and right. Okay, then we will compare the value with the global, that which one is the maximum. Okay, and after that we will return the maximum single path sum, a node that can contribute to the path by choosing the maximum of the node of the left and the right sum. Okay, means like a node, whatever the node is there, plus the left sum, or either the node plus the right sum. Okay, so let's start with the implementation. As you see that tree is already defined here, we just need to write the actual code. So we need a global variable as we discussed. So first step will be global. So we will keep it a maximum. Now we have to write it inside this. So first we will initialize with the lowest possible value, that is inside a max, which we already defined outside this. Okay, so inside that we will put a default value. Fine. Next we need a helper. Okay, where we will calculate the maximum. I'm putting max path some help. Okay, and inside that I will keep it root. Right, and whatever I will get it at the end, I will just simply return the sum. Right, let me define this helper. Okay, private static and inside that we need tree node and keep it the name as node. Okay, now first have to check the base. Okay, that node is equal to null or not. If it's null, we just simply return 0 from here. Right, otherwise we have to recursively calculate the left and the right max, whatever the right max, like we have to recursively calculate the left and the right maximum path sum. Okay, whatever we are getting from this area and there, we just need to get it that value. So int left max equal to math dot max, where I will keep it. And as you know, we will have to ignore the negative values also, right? I start this, I have to pass this only. Boot dot left, right? And same have to do it for the right also. I'm just copying it. Mm-hmm. Copy, paste. Right. Now, now we have to compute the current node maximum path. So I'm defining a variable here. What is the current max right now? So node plus value wherever we are plus left max plus right max. We whatever we get it. Let me terminate this. Now we have to update the global variable now. Okay. To dot max, inside this I'll pass maximum or either the value which we have currently calculated. Current max. Right? And at the end we have to return it. Return no plus, well, whatever the current value we have, plus math dot max. Inside that we have to pass left and the right value, right max. Okay, and the left max will be there. Is it now done? Right. Let me run this. Okay, it's got accepted. Let me submit this. Okay, it's got. Let me explain the step by step. First, we have added the base case, that is the node is null or not. If it's null, we just simply return 0. So we just pass the base case if it's happened. Otherwise, we have calculated the left and the right max. Okay. So, okay. Then after that, we have because we want to ignore the negative cases, so we have used the math max. Where is that? This case, okay. For this case, we want to ignore the negative cases. That's why we have written like this. And after that, we are updating the maximum path. That is, we are doing at the line number 29, where we are calculating the max value. And then after we are comparing with the global variable, which is the greater, whatever the greater, we are just keeping it. And then we are returning the valid contribution, which is a node can be contribute to the maximum path either through like left subtree or either the right subtree. Okay, either from this side or this side. So that's why we just at the end we are returning that whatever the current node we value we have, and after that whatever we are getting from either left or right, we are just getting that value and just simply return it. And if you talk about the time complexity for this case, so the time complexity is of n only, where we, because we are just simply visit each node once only. And if we talk about the space complexity, so for this case it will be O of h, where the h is the height of the tree. Okay. So I hope you got the solution. And the key points to be noted here, we have used the DFS. Okay. and the recursion to compute the maximum sum path of each node. Secondly, we have maintained the global variable, okay, to track the highest possible sum up of the path. And then we have ignored the negative cases, as we have to reduce the overall sum, because there is no usage to take these negative values. Okay, then we have returned the maximum thing. Okay, so this solution ensure that we have find the maximum path sum efficiently, and is widely used in the coding interview.